Hey, good morning, everybody. This is Mr. Aynesworth again. We're going to get into a few more examples of how to graph translated sine and cosine waves, which is not an easy topic right in the beginning. So in my first video, I only went through example 1, as you can see right here. So let's go through a few more. And remember the definitions up top here. Refer to that if you don't have them memorized here, but P stands for period, which is the distance between two successive maximums or minimums. There's a way visually to calculate the amplitude, but if you can't see it, you just take max minus min and divide that by 2, and you'll get your distance above the midline or the wave axis. The shift is just the translation, how far you have to shift it from an untranslated sine or cosine wave, and the wave axis, or what you guys call or may have heard as the midline, is calculated by taking the average of the max and the min, which simply means you just add them up and divide by 2. And then that value there is y equals k, and it goes right through the wave. All right, it's actually part of the shift. So when you know the shift right here, all right, right there, then you know the wave axis or the midline or the equation of the midline. So let's get right through it here. Okay, the first thing we do is we find the period, all right, and from the period we can figure out what b is. So again, the period is the distance between two successive maximums. So let's do it here. All right, so I see a max up here, and I see another one over here. And you can pick any two maximums if you want. So from 0 to 4, so right here, this distance right here, the period is 4. Now I know that the period in general is the period of the function divided by the coefficient of x, which is b in general, and this is equal to 4 here. So if that's the case, you could also say that if p is equal to 2 pi divided by b, that means that b is 2 pi divided by the period, and since I know the period, it's 2 pi divided by 4, or just a half a pi or pi halves. So now I know b, the coefficient of x right there. Now, you should always draw the wave axis, and it runs right through the wave. So if the maximum is at 4, there's a 4 up here, and the minimum is at 0, well, the midline has to go right through it too. So I'm going to draw it. Okay, so y equals 2, and this is called the wave axis WA, or midline, whatever phrase you want to use. The midline it's in the middle of the wave, or the wave axis is what divides the wave in two parts, the upper and the lower. And that is equal to y equals 2. But what's the shift for cosine, and what's the shift for sine? They're two different shifts. Remember, every graph can be written as two possible functions, one for sine. Okay, first one's sine. And then the second one could be written in terms of cosine. You can write the wave either way you want. Test them in Desmos here. You get the same graph, because every cosine wave can be written as a sine wave and vice versa. Okay, so what do I know? Let's start with sine. Okay, now sine typically starts at the origin. Everybody knows that because you know that you've had that mastery. So sine starts here, typically untranslated. Okay, obviously this this curve has been translated. So what's the possible starting point for the sine curve? There's a couple possibilities. You could start here at point A, okay, because it goes up and then back down, or you could start at B. So you can start at A or B here. B is right here, okay, or you can start at C. So what I usually tell my students, or you can start at D actually. So either one of these 4 points, so A, B, C, D, you got to pick one. So usually what I tell the people, or tell students, is just pick the one that's closest to the origin, okay, that has positive coordinates, okay, which is obviously B. So how do you get from the origin to B? Well, you simply go right 3, okay, right 3, and you go up 2, okay. So the shift for sine, and again, this is for sine now, is remember, it's always h comma k, which is 3 comma 2. So there's your shift. Now an untranslated sine curve with a period of 4 and then b is equal to pi halves. So untranslated, this is what it looks like. Untranslated, translated. Looks like y is equal to 4, because again, the period's 4. Excuse me, I'm sorry. The amplitude, I need to look at the amplitude. Oh, I haven't found the amplitude. Got to find the amplitude, sorry. Drop of the gun. The amplitude is distance between the wave axis and the max. And so the amplitude here is obviously 2. Okay, you can see that there. You can also see it over here, the distance between the wave axis and the min. Okay, so you can see it here as well. So between the wave axis and the max, or the wave axis and the min, is the amplitude, and the amplitude is 2. Okay, so you need to know that to write the function. So with a period, with b equals pi halves and amplitude of 2, an untranslated sine curve looks like this. Okay, so you start off with the amplitude. A is amplitude, so 2 times the sine of pi halves, because that's b times x. That's untranslated. So you want to translate it though, because this function, has been shifted off the origin here. It doesn't go through the origin, and the wave axis is not the x-axis. It's been translated right 3 units and up 2 units. All right, so the way you write that is you say, okay, I know the amplitude is 2, and you take sine of now pi halves times x minus the h value, okay, which is 3. Okay, it's been shifted right 3 units. And then you have to add the k. Well, you have to shift it up 2 units, so you got to add the 2. So again, that's h and that's k. So you got to find the period, and then you got from the period you find b, and then you need to look at the graph and find a, the amplitude, the distance between the axis and the max. And then for sine, you got to pick a point where you can start it, okay, either at a, b, c, or d, and then you simply write the function. And then, of course, you test in decimals. And we'll do that just for fun, just so I can show you. Okay, and then cosine, though. Cosine is different. So let me switch colors. Now, cosine, with an amplitude of 2, cosine would start here. So 2 units up on the y-axis. So write down cosine starts here with an amplitude of 2. So untranslated, let's see what it would look like. Untranslated, it would like y is equal to 2 because it has an amplitude of 2. Cosine of pi halves x. That's untranslated, or not shifted, okay? So, but this thing's been shifted, so it doesn't start at 2, as you can obviously tell. So remember cosine, the cosine starts like this. If this is the x-axis here, you go up 2 units, okay, and then it goes down, up, and so you start at a max, so you go max to max. But notice the max is 4 units up and not 2 units up. So this obviously has been shifted, okay, shifted up 2 units. So shift up 2 units. So for cosine, the shift is 0,2 for cosine. This is for cosine only, because cosine starts on the y-axis at whatever the amplitude is. And it usually starts at 2 here, but this cosine wave has been shifted, the whole thing's been shifted up to 2 more units. So my shift for cosine is 0,2, where h is 0 and k is 2. And now I could write my function. So y is equal to the amplitude of 2 times cosine of b, which is pi halves, times x minus h. But again, there was no need to shift it right or left, so it's 0 there. But you got to shift it up 2 units, so you add k. And then, of course, you simplify this because x minus 0 is just x. So 2 times cosine of pi halves times x. All right, put that in parentheses, and then shift that up 2 units. And now you check with decimals. So we're going to do this here. Check with decimals, because if you didn't have my answer keys in Canvas, well, guess what? No worries. You get your best friend's decimal. So here we go. So let's do this here. Let's check the first one here, the sine function. And let's type it in. So y equals 2 sine. So 2 times the sine of pi divided by 2. So pi divided by 2. All right, I need to take x times x minus 3. So x minus 3, close it off. And I got to add 2 units up. Okay. And notice what we have here. So this one here, if you take a look at the graph right there, let's see here. Notice it starts up there at 4. Okay, just like the graph over there on the left in my OneNote. Okay, and then it hits the x-axis at 2, and it goes back up at the max at 4, 4. You can just compare it. It's the same graph, you guys. Okay, now let's check the other one. So checking the other one. Now, if I type in another function, I only see one curve. That means they overlap, and I'm correct. Okay, so here we go. So y equals 2 times cosine now of pi halves. So pi divided by 2. All right, times pi halves x. So, I should have just times x here. There we go. All right, so I got pi halves times x, and then I have to shift it up to units. So notice that I see two graphs because this thing has not been shifted yet. As I said earlier, untranslated, it looks like 2 cosine of pi halves x, which I just wrote down in Desmos. But you got to shift the whole thing 2 units up. So you simply add 2, and it becomes the same graph. All right, so let's screenshot this baby here. All right, and bring it in so you remember how to do it and how to check your work here. Oh, you know what I want to do? Let me delete that. Okay, we want the points here so you can see. All right, so I got the points in here, and then you screenshot it, and then you bring it in because now we have points. We can see that it's actually the same function. Okay. Oh, I didn't get I need this right here. There you go. All right, and then let's bring this in. This is some cool. I love working on the iPad because you got some cool technology here to allow it to obviously record your work. So there we go. So there you have it. There's the record of that, and that verifies everything. So this right here is the same as this. So check with Desmos. All right. Oh, there's one more. Let's do another one. What the heck? I feel motivated. All right, even though it's like started at 5 o'clock in the morning here. All right, so the period, distance between two maximums. So you find a max here. Okay, and that's obviously at 2. And then you find another max. And that's, just look straight down here. Okay, that's at 10. So the distance between 2 and 10. There we go. All right, is your period. So 10 minus 2 is 8. So my period is 8. Okay. So now that I know the period is 8, right, I can find b. So if the period is 2 pi divided by b, that means that b is 2 pi divided by the period. So this gives me b is equal to 2 pi divided by 8. You reduce 2 eighths, you get a fourth. So you get pi fourths. So b is pi fourths. So keep that in mind. Amplitude can be seen if you draw the wave axis. So let's draw the wave axis first. The maximum is at 4. Looks like the minimum here is at 2. All right. And so the wave axis has to go right through the middle. So that's at 3. So the wave axis here is y equals 3. So let's draw it. It splits the distance, right? Okay, so there's y equals 3, and there's your wave axis, or the midline, however you want to call it. So I know the wave axis is y equals 3. The question is, what's your shift? Okay, so now you start with the sine function. Okay, every time you're given a graph here, you can write 2 possible functions given the graph. So let's start off with the shift for sine. Now sine typically starts at the origin. So sine starts here typically, untranslated. Okay, so now you have to find a possible start place. Okay, so you need an up-down cycle. So we have some choices. We could start at point A. Okay, not at B. Okay, you can start here at B, either A or B, but which one's closer? So let's start at A. So how do you get from the origin to point A? You simply go up 3. So your shift is up 3, But the way you write that is 0, 3. And that is for the sine. So 0, 3 is your shift, where this is h, k. Okay, now untranslated sine curve with a let me see, amplitude. What's the amplitude? Oh, I haven't found it. So the amplitude is from 3 to 4, which is obviously 1. So the amplitude can be seen there, or from the wave axis to the minimum. So the the amplitude is 1. So when A is 1 and B is pi force, an untranslated curve, sine curve looks like y is equal to 1 times the sine of pi force times x. Okay, that's what untranslated sine curve looks like. Now, this one's been shifted up. As you can see, it's off the axis. I mean, it's off the x-axis way down here. So I got to shift that up 3, so that's simple to do. So I take 1 times sine, which is just sine of pi force x, all right? I don't have to shift it right or left, so it's pi force times x minus 0. And then I have to shift it up 3 units. Okay, so I add 3, and then you simplify it. Y is equal to just pi force times x, right? Because x minus 0 is obviously x right there, and then you have to shift it up 3. All right, and I'll verify this in Desmos here in a minute. Okay, so then the other one here, cosine. Now, with an amplitude of 1, let me switch to green here. With an amplitude of 1, cosine would start here. Starts 1 unit up. Okay, at 1, because the amplitude is 1. Okay, remember, cosine starts at a maximum, not at the origin. So, how do you get to a max? Well, I can, see, point C, up here at C, let's call it C up there, or up here at the other max, oops, let's go in, yeah, you can see either start at C or D. So you can write this 2 different ways given the graph here. You can use point C, or you can use point D. It doesn't really matter, but you want to figure out how to get from 1 unit on the y-axis to point C, which is very simple. Let me just change something here, bring this down. Okay. So from C, all right, to, from the 1 unit above here, all the way to C. So I got to go right, and then I got to go up. So I got to go right 2 units, and from 1 to 4 is an up 3 units. So my cosine shift is 2, 3. So untranslated, I always start off with that, so you understand what in the world you're doing here. Is y is equal to 1 times cosine pi force x. That's untranslated, but you're using a shift of 2, 3. Remember, this is h and this is k. So a translated one, the one you're looking at on the graph, looks like 1 times cosine of pi force. And you got to shift it, so you got to subtract 2 from the x-coordinate. Then you have to add 3 to shift it up 3. So again, this is right 2. And this right here is an up 3. And that corresponds to everything you learned in the prior units in first semester when we talk about transformations. A horizontal transformation, a horizontal shift, you always add or subtract something from the x-coordinate. And then a vertical shift, you always add or subtract something to the y-coordinate. Okay, now let's check with Desmos. All right, here we go. All right, turn off the colors, but save your work here, okay? So type in y equals, all right, sine, all right, at pi force x, so pi divided by 4. All right, multiply that by x, and then you simply add 3 to it, and then you check it. So if you check right here, I'll notice that my curve starts at 0, 3, which corresponds to the left, and the point C is at 2, 4, and so is this on the graph. That's how you check. The other one here, y is equal to, see the cosine curve here, so y equals cosine now, a pi force times, so pi divided by 4. All right, I want to use parentheses. I got to take x and subtract 2 because I got to shift it right 2 units. And then I have to add 3 to it and bring it up. And notice you have only one curve because they're the same functions. So here, just plot a few points here, and then screenshot it, bring it into your lesson. All right, so you can remember what you did in Desmos. All right, so let's do this. Let's bring it in, just so that we can have a reference picture in Desmos here. There we go. All right, so you can see your work that you did. All right. There we go. And that's how it's done, my friends. Okay, so I went over 2 examples today. All right, this is how you write a function. All right, writing a function using or given a graph. Okay, this is Mr. Aynesworth. I hope to see you in class. I hope this helps you out, and we'll talk to you soon.